All right, so this one can be a little bit tricky, especially if you're rusty on your geometry. But let's have a look. So the figure above shows a regular hexagon with sides of length A. Okay, so I've sort of marked that, and a square with sides of length A. And that's sort of suggested by the fact that they share a side here, and we're basically told that this is a square. So that means, all sides are equal and all, which means that if this is A, that means this also has to be A, and so on. So these are all A. Cool. If the area of the hexagon, let me just write that down over here. If the area of the hexagon, so let me just, area H, is 384 square roots of 3 square inches, what is the area of the square? So how can we even begin to tackle this? The key here, and I think once I make this step, you'd be able to, definitely make some progress. But so the first critical step that you have to do is that you divide this hexagon into triangles. And the even more critical detail here is that you just if you didn't know this prior to this, watching this video, then that's not a problem at all. But just moving forward, keep in mind that if you do this, these are equilateral triangles, and that's really your critical detail here. Also, this is a kind of a rare type of problem, so like don't be too stressed out about this, but still just go through and make sure you understand how to solve this type of problem. So we divided it into 6 equilateral triangles, and what do we know about each of these? Well, we know that each of them will have an area of this divided by 6, right? Since there are 6 triangles and they're all equal, so let's just go ahead and do 384 square roots of 3 over 6. Which is, let's see, what's that equal to? 384 over 6. Okay, so this is equal to 64 square roots of 3, because 384 over 6 is 64, and then this sort of stays. So this simplifies to 64, and the square root of 3 stays. So this is the area of each triangle. So let me just say area of T. How can we actually do or use that? Well, so we know now that we have these equilateral triangles with this area, and we know that all the sides are A. It's equilateral. What do we actually need to figure out? We need to figure out what the actual value of A is, so that we can just then, multiply A twice, or, do A times A, and then know the area of the square. So that's sort of my plan. And how I'm going to try to figure out the value of A is just use our formula for area of a triangle. How am I going to use it? Well, we know that area of a triangle is base times height divided by 2, or times 1/2, or 1/2 base times height. It's a little bit weird way of writing it. But so the question, so here's the height. We don't actually have the height, but we have the base, which is A. How could we express the height? Well, let me draw a bit of a bigger picture here so we can zoom in. So here we go. If this is A and all of this is A, so each one of these sections, let me call this right here 1/2 A, right? This is 2 pieces of 1/2 A that make up this total length A. That means that this length right here, by Pythagorean theorem, is going to be A squared minus 1/2 A squared square root. This is equal to H. And let me explain that just a little bit. So the reason I'm saying that is because we know our Pythagorean theorem is, A squared plus B squared equals C squared hypotenuse. So that means that in this case, that our, so one side squared, that's 1/2 A squared, plus the height squared, which I'm just going to go ahead and call H, height squared is equal to the hypotenuse squared, which is A squared. And so if you just rearrange this to solve for H, you'll get this, because if you subtract 1/2 A squared and then square root both sides, this is what you get. So this is our height. How can we actually use this information now? Well, that means that we can now take this formula, let's just scoot this over here, and we can write everything in terms of A, because what is our base? Our base is 1, sorry. For our whole triangle here, our base is A. I almost wrote 1/2 A, but that's not the case. We're trying to find the area of this whole triangle. So the base is A. The height is what we established right here by dividing it like this. This height is going to remain the same whether you're talking about this triangle, just this one, or this entire thing. So the height is the same, which is, so A times the square root of A squared minus 1/2 A squared, like this. Make sure to put it on the outside of the parentheses. That's critical. This times that times just 1/2. Well, why is that useful? Well, because now we can set this equal to the area that we know for the triangles, which is 64 square roots of 3. 64 square roots of 3. Sorry, getting a little squished and messy here. But so we can set this equal now, and now we can just solve for a because we got it all in terms of one variable. So let me just quickly recap how we got here. We basically knew that we could divide these into triangles. We then understood that they're equilateral, which you just got to know that. And from there, we divided the total area by 6 to get the area of each individual triangle. And from there, we are moving forward by writing the area in terms of a, because we know we got this height in terms of a. We know the base is already in terms of a, so we can write our formula for the area of the triangle like this. Now let's just solve for a. So let's start by just multiplying both sides by 2 to get rid of this 1/2. So that means you'll have on this side left over a times a squared minus 1/2 a squared is equal to 128 square roots of 3. From here, I would suggest just squaring both sides. I think that would probably be easiest. So how you can do that is, well, there's a few ways to go about doing this, but let's go ahead and, let's just square both sides. So if you square this side and square this side to get rid of all the square roots, here you basically get a squared times, so it's like a times a, and then this times itself, so that just removes the squares, so it's a squared times a squared minus 1/2 a squared parentheses, okay, equal to, same thing here, 128 times 128, which is equal to a very large number, 16,384 times square root of 3 times square root of 3 is just 3, so just times 3. From here, you can go ahead and distribute this a squared, so that makes this a to the 4 minus, let's go ahead and square this and then distribute. So this squared is going to be 1/2 a times 1/2 a, so that's 1/4 a squared, which makes this, okay, 1/4 a squared, but then you distribute the a squared to it, so that makes it just a to the 4th. This is all equal to this times 3. Let's just put that in our calculator. 49,152. Okay, so I hope the algebraic steps I've made so far are clear. Again, just squared both sides to get rid of the square roots. Here's what we got. I just worked this out over here. I'm sorry, I did a little bit out of order, but worked this out over here and then distributed the a squared to both. From here, how do we actually solve this? Well, these are both a to the 4th terms, so we can just combine like terms here. So what's like 1 over 1, or let's write it actually as 4 over 4 a to the 4 minus 1/4 a to the 4. That's 3/4 a to the 4 is equal to this big old number. From here, we can just divide both sides by 3 to the 4 to isolate our a to the 4. Okay. Divided by 3 to the 4, the same as multiplying by 4 over 3. So either way, you can just type that into your calculator, and that'll give you, let's see, that'll give you 65,536. And finally, how do you actually isolate for a? You take the 4th root, right? Not the square root, because it's not squared, it's the 4th root. Alternatively, you can just take the square root twice. So here we go, 4th root of a to the 4 and 4th root of this. That's really the key point. So 4th root of a to the 4 is just going to be a. 4th root of that big old number is 16. Okay, so we just figured out finally that a is equal to 16. Is that the answer? No, because a is just the length of one side. So what's the answer? If a is 16 and this is also 16, how do we find the area of the square? 16 times 16, which is 256. Whew. All right, congratulations on making it all the way through that. I hope that makes sense. So once I think you'd agree though that once you break this into the triangles, you can sort of work it out from there, but you really need to make that sort of critical first step. So there you go.